You have a file, hundreds of driving test results. Some passed, some failed, some are just broken. And if you try to count that manually, good luck. So we're going to write maybe 20 lines of Python and turn it into a fully automated inspector. It reads the file, catches the garbage, counts everything, prints a clean report, no spreadsheet, no manual work, just Python doing what Python does best. Let's get into it. First, we have one problem. The file is on our computer, but Google Colab cannot see it directly, so we need to open a small door between our computer and Colab. For that, we import files from Google.Colab. Then we write files.upload. This gives us an upload button. We choose the student's file, and now Python can finally work with it. The investigation has officially started. Now we have a small problem. The file could be called students.txt or driving_results.txt or any other name. So instead of typing the file name manually, we let Python find it automatically. Uploaded.keys gives us the names of the uploaded files, but it is not a normal list yet, so we convert it into a list. Then 0 means, give me the first uploaded file. So now Python knows the file name without us writing it manually. Before Python starts reading the file, we prepare 3 counters. 1 counter for people who passed, 1 counter for people who failed, and 1 counter for unknown results or broken lines. All of them start from 0 because Python has not inspected anyone yet. Now we open the file. The R means read mode. Python will only read the file. It will not change it, delete it, or overwrite anything. And we use with open because it is safe. Python opens the file, reads it, and when the job is done, it closes the file automatically. It is like opening a notebook, reading from it, and closing it when you finish. Python does not read the file as one giant block. It reads one line, checks it, then moves to the next line. Here we use enumerate. Enumerate gives us 2 things, the line number and the actual text inside that line. We use start equals 1 because humans count lines from 1, not from 0. So Python says, I am on line 1, and this is what I found. Then line 2, then line 3, and so on. For us, this line is easy to understand. Ahmad, 25p. We see a name, an age, and a result. But for Python, this is just one piece of text. So we use .split. .split cuts the line into pieces wherever there is a space. So this, Ahmad 25p becomes this. Now Python can handle each part separately. Now Python becomes a real inspector. It expects every line to have exactly 3 parts, name, age, and result. For example, Ahmad 25p. But what if Python finds this? Ali 20. Now we only have 2 parts. The result is missing. Or what if it finds this? Wrong line. Too many words. Now we have too many parts, and the structure is broken. So we write, if len data does not equal 3, this means, if the number of parts is not equal to 3, this line is not valid. Then we print a warning message. We increase the unknown counter, and then we use continue. Continue means, skip this bad line and move to the next one. This is what makes the program strong. If we reach this part, it means the line passed the first inspection. It has exactly 3 parts, so now we can give each part a clear meaning. The first part is the name, data 0. The second part is the age, data 1. The third part is the result, data 2. But notice something important. We also use upper parents. Why? Because someone may write lowercase p instead of uppercase p. So instead of treating that as a mistake, we make Python clean it for us. This small step makes the program smarter and more forgiving. Now Python starts making decisions. First question, is the result equal to p? If yes, this person passed. We print a clean message, passed the driving test. Then we increase the passed counter by 1. Notice the idea here. Python is not waiting until the end to remember everything. It counts while it reads the file. Every time it finds a passed result, the counter goes up. If the result is not p, Python asks the second question. Is it F? If yes, this person failed. We print a message and increase the failed counter. This is the beauty of if and elif. Python is walking through a decision path. Is it P? No. Is it F? Yes. Then this person failed. But real-world data is not always clean. What if the result is X or Z or anything that is not P or F? Then Python reaches else. Else means if it was not P and it was not F, then it is unknown. The program does not crash. It prints a clear warning and increases the unknown counter. This is one of the most important lessons in real programming. Never assume the data will always be perfect. After Python finishes reading all the lines, we reach the final report. The messy file becomes a clean summary. We print a separator line to make the output easier to read. Then we print the total number of people who passed, the total number of people who failed, and the total number of unknown or invalid lines. This is the power of automation. You give Python a messy file. Python gives you a clean report.